Now, we've already seen how do we build linked lists in Java and some of the things that we can do with building a linked list. Now let's look at the linked list that Java gives us. That is, it has a built-in collection object. It's part of the bigger collection group of objects that we can use. So let's see how we would do that. Notice I've already imported java.util, as that's where these objects lie. And I'm going to come over here and specify linked list. Notice that it's right there. Now, just like C++ has templates, we're going to use the template in Java here, and I'm going to use string. Now, I could use any other type of class that I want to. It could be customer, product, student, whatever. We're just using something for simplicity's sake. And call my list equals new linked list. And once again, I have to specify in my angle brackets that this is a linked list of strings. So this is how we're going to create it. This is actually one of two methods that we can use to create this. I can also pass in another collections object, and I can build it from there. So the only difference is, do I have existing data that I can bring in, or am I just going to be creating an empty linked list? For this example, we're just going to create something empty. So let's go ahead and add something to this linked list, because having an empty linked list is pretty bland. So I'm going to say list.add, and then I'm going to specify what is it I'm going to add. Well, I'm going to add the element A. This is just real simple. It's an easy thing to do. And then I'm going to say list.add, and I'm going to put B. So these, once again, are just real simple examples. Next, I'm just going to print this out. To print this out, I could loop through each element, or because it's an object as a toString, so I'll just say system.out.println, and I'll specify list. If I run this, you'll notice that it prints inside of square brackets. Here's an A, comma, B, and this will continue on for however many elements I have. So I don't have to worry about using like a for loop to iterate through this to print it out. It gives me a real quick, easy way to check. Notice that as I add elements, it adds them to the end. So I could also say list.addLast, and it's going to do the same thing as add. It's going to append it to the end of my list. So you know it's A, B, C. However, I also have a list.addFirst. And if I put D in there, you'll notice that it's going to prepend it at the beginning of my list. So I'm not limited to adding at the end. The add's going to do that by default. The add last is going to put me at the end. Add first puts me at the beginning. So if I want to add something in the middle, add is actually overloaded. So I can say list.add, and I can specify an index. In this case, I'll do 2, and then I will do element E. If I run this, you notice it does D, A, E, B, C. So why did it put it there? Well, that's where the index would be. So it's 0, 1, 2, E, puts it right there in the center. It pushes everything else down. Remember, as a linked list, my items are linked, and so I can insert things in the middle. Things naturally get pushed down. Now, does it actually get stored that way inside of Java, inside of its linked list? Here's the thing. We don't care. Could they be using an array or a vector or something else? You bet. That is inconsequential to us. Remember, we think of objects as a black box. How they work internally, we don't care. We only care about, hey, if I call this method, does this consistently happen? And we can see this. What happens if I want to remove an element? Well, I can say list.remove. You might think, okay, well, what does that do? Well, let's print it out and just see what's going to happen. So I'm going to clear my screen down at the bottom of my terminal window. Run this again. Notice that it removes my very first element. And if I hover over this, you'll notice it says it retrieves and removes the first element. Well, wait a second, it retrieves. Does that mean that I can put something here? Well, we're going to change this real quick. We're going to say string letter equals list.remove. And then if I say system.out println letter and run this, you'll notice that not only did I remove the element, I store it into a new string. So remove does two things for us. If we don't put it into a variable, it's just gone, and that's okay. If we do, we can do that as well. But just like with add, I'm not limited to remove. I can say list.remove, and notice I can remove an index. I can remove a specific object. I can remove the first, the last, the first occurrence, or the last occurrence. So if I have duplicate values in my list, I can choose, want to remove the first one or the last one. If I have one in the middle, then I'm going to have a little bit of a problem, because that means I'm probably going to have to use the index to figure out where am I. You'll also notice I have things like I can replace, check to see if something contains an element, etc. Now there are a few things about the linked list that I don't care for. For example, I can push an element. I can also pop an element. Now you might think, well, why don't I like that? Well, push and pop are both specifically named functions for a stack. Okay? That's not something a linked list is going to do. So I shouldn't have to worry about that. Now the good news is if I come in here and try to maybe enqueue or dequeue, notice that they're not in there. That's okay. And I'm actually happy about that. But I don't think that push and pop should be in there. So if we're going to use it as a pure linked list, we need to remember that just because Java gives us some built-in methods doesn't mean we have to use them. Okay? The one other thing that I'm not a big fan of about the linked list is I have a really hard time figuring out what my current index is. Now, one other thing that you might notice is that with our list, we don't have a way really of getting the current index. So if I come over here and say list dot and try to get like current or index, notice that I can't do that. I can get the size, I can get an element at the index of, but I can't get those values. So the question is, do I need to for that problem? The answer is usually not. Linked lists don't have to be sorted, so unless you're going and trying to sort them or something like that, it's probably not a real issue. So that's just something you have to kind of keep in mind. Is this a real issue for me to work with? And the answer is probably, like I said, probably not. But I can get a value at a specific index, so if I do keep track of that index on my own, I can still get the appropriate values. I can use the for each loop inside of Java, or I can use a traditional for loop, and then use something like size in order to test against to make sure I don't go outside of my bounds of my linked list. So while it's not a perfect implementation of a linked list, it is a pretty good implementation, and we don't have to worry about coming up with it on our own. If we need a more perfect solution, then we can go back to our previous examples and take a look at how to do that. There is an example, and in the comments section below, I've created a pinned link which will take you to that information. If you want to keep looking at this, there is links below that will tell you how do you get to do a regular linked list and create one on your own, as well as other types of collections that you might want to look at that Java gives us to work with in this playlist.